Okay, so the second lecture of today, fourth lecture of Simplex. We're going to do, in the last week we did the theory of initialization and we also did an example. Today we talked about how to iterate, we went over that, and now we will do an example. Before that, some better quality joke. Okay, teacher, why is your paper blank? Student, sometimes silence is the best answer. This is second grade. Second one, wife, had your lunch? Husband, had your lunch? Wife, I'm asking you. Husband, I'm asking you. Wife, you're copying me. Husband, you're copying me. Wife, let's go shopping. Husband, yes, I had my lunch. Slightly humorous. Okay. All right. I talked to you about that marriage is an NP-complete problem. Did I tell you that joke? Well, that's the joke itself. There is no ideal marriage. So there is no optimal solution to it. You have to always keep finding heuristics. So that's why marriage is called as an NP-complete. You have to adjust and figure it out. Okay. Alright, so now we did iteration. So I've written the algorithm, I've written the initialization part. We want to iterate together so that you understand the steps better. This algorithm is already uploaded on the drive because you want to code it today and test it. So this was the initialization part, which now I'm repeating the nth time. So I'm not going to repeat it. What we did today was, if all indices of mu are greater than 0, then you're stopping because you found the solution. This is what we understood today. So the very first thing is you pick an index q from the n set where mu q is 0. You solve for bd is equal to aq. This was the d which we were solving of b inverse aq. If all d components are either negative or 0, then you stop. Why? Because the problem is unbounded, which you're going to prove in the failures section whenever we do that. But assume that at least one component is positive, then you do the most important or the most crucial step of Simplex. Find the xq plus by minimizing xbi divided by di for the di's which are strictly greater than 0, and that minimizing I is referred to as p, the index p which you will kick out from the b set. Okay. Once you are done this, then you are done. This was the step which we wrote when we wrote xb plus is xb minus xq plus. We had written this as b inverse aq when we were deriving it. Xn plus is all 0 with one non-zero component which you made it xq plus. Now you have a non-zero here, and once you will solve this, all of them will turn out to be greater than 0 except the p component which will be equal to 0, and the remaining would be greater than 0 once this xb plus will come out, because that is how we had chosen the xq plus which you showed you in the example. So now you've got a 0 in the xb plus and you got a non-zero in the xn plus, and you're going to swap them. That is what is written. Take the q out of, add the q in the b set and take the p from b to the n set. Okay. Now we're going to make this more clearer to you with an example. So the example is same which we did last week, not last week, 2 weeks ago. So this is your LP. This is actually 4-dimensional LP. I don't know why I was using 5n as the example to explain. So there are two equality constraints. The x is 4-dimensional, so it's an n is 4, r is 3. We write it in the standard form C transpose x, ax equal to b, and then we initialize. To initialize, we had done this step earlier, satisfied these two. So you help me with this. What is xn? जल्दी जल्दी यार, जेई किया हुआ है, इतनी तेज इतना सोचोगे तो जेई कैसे क्लियर किया? 0. What is xb? xb is b inverse b. What is b? What is the b matrix? Jago, it's the identity matrix because 3, 4, no? The third and the fourth column, so it's the identity matrix. Identity matrix inverse is identity matrix. What is B? B is 5 comma 8. So this is 5 comma 8. Yes, we did this 2 weeks ago. What is lambda? B inverse transpose times CB. This is again identity, so doesn't matter. What is CB? CB is these two. So we'll write them as 0, 0. It has to be written as a column vector because this is C transpose, remember? And that's why it's written as a row here. Then, what is mu B? That is forced to be 0, 0. And what is mu N? Cn minus N transpose lambda. Lambda is 0, so this term doesn't matter, so it's just the C of N. C of N is minus 4 and minus 2. Now let's write the objective function value. Why I am writing the objective function value? Because I want to show you that when you go from one basic to the next, the objective function value reduces. So let's just compute it. So this is C. What is X value? What will be the X value? Tell me. So 1 comma 2 is coming from the N set, which is 0, 0. 3 comma 4 is coming from the B set, which is 5 comma 8. So this is 0. Yes? Everybody with me? Okay, now let's iterate. Okay, so iterate. What did we got? We got both the elements of the N set to be negative. So we have to pick any one. So I'm going to pick the first index. So I'm going to take the first index. The first index is, so my Q is 1. So I'm taking the first index. I can take the second also. It does not matter. So my Q is 1. Remember that P and Q refer to the indices of the overall set. They don't refer to within the B and N set. That is not what they are. So Q is N. So now I have to solve for this guy. Correct? So what is my D? BD is equal to AQ. B is the identity. So D is nothing but AQ. AQ is the first column of the A matrix, which is 1, 2. 1, 2. Okay, now we go to the next step. Are all D's negative? No, so both are positive in fact. So now we'll calculate this guy. We'll calculate XQ plus. To do that, we'll do XB1 divided by D1 and XB2 divided by D2. Correct? What is XB1? 5. What is D1? 1. What is XB2? 8. What is D2? 2. Which is minimum? This one is minimum. It gives you value 4. So your XQ plus is everybody with me? Or XQ, we already know the Q, so I'll call it as X1 plus. Okay, just to remember. What else was there in the N set? N contains another element 2. So X2 plus is zero. You are enforcing it, right? All the others are 0. What is happening to X? What is your P now? What is your P? Yeah, it's 4. Why? It's the second index of the B set. The second index of the B set is 4. So P is 4. It's the minimizing I. Everybody with me? So which means that I would get X 4 plus is equal to, in fact I will substitute in this, it will be 0, but let's solve for this. So we'll substitute in this. So we'll say xb plus is equal to xb, which is 5,8 minus, what is d? 1, 2, and what is xq plus? This is your xq plus. So this is 4. This is xb plus. So this is x3 plus and x4 plus. This is 5 minus 4 is 8 minus 8 is 0. So your x4 plus became 0 and x3 plus stays greater than equal to 0. Can everybody see? So there is one element which is made in xn made greater than 0, and there is one element p in the xb which is equal to 0. So now p is equal to 4 and q is equal to 1 will be swapped. Yes or no? What I didn't show was that the new b stays non-singular by the swapping, which we'll worry about later. But in the example you can easily see it. So what I'll do, I'll erase this now. I'll keep the algorithm on the board. Is that okay? So your old b was 3, 4 and your old n was 1, 2, and you got your this to be your p and this you took your to be q, so they will be swapped, correct? So your new b would be 3, 1 and the new n would be 4, 2. Don't try to sort it, place it where you're kicking it out. So if p is coming out from the second index of the n set, then the q will go in its place. Don't change the order. Okay, now what do? We initialize, we restarted. यहाँ पे आ गया ना, अब फिर से वापस you go back up, given a b and a n, initialize it and then check for mu and n and then stop again. So we'll initialize again. So I'm keeping this place open because I'm writing this. Okay, so to initialize we had to write xb is equal to d inverse b. Now what is b? Let that C transpose x be written. So it's minus 4, minus 2, 0, 0, x1 to x4, and let ax equal to b also be written. So that was 1, 2, 1 half, 1, 0, 0, 1, x1, x4 equal to 5, 8. यही था ना, कुछ और था. 1, 2, 1 half. ठीक है. So now what is your B matrix? B is the third column and the first column. The third column and the first column. Correct? So I'm going to write that in that order. 1 0 1 and 2 inverse times 5 8. Once you solve for this, you get 1 4 and your xn anyways is 0 0. Then you will solve for lambda. Lambda is b minus transpose cb, which is 1 0 1 2 minus transpose cb. What is cb? Third element and the first element. Yes or no? So that's 0 and minus 4. Once you solve for this, you get a 0 minus 2. I'm solving it. You'll have to find the solution. Then we know that mu b is equal to 0 and mu n is Cn minus n transpose lambda, which is Cn is the fourth and the second. The fourth and the second. So that's 0 and minus 2 minus the n is the fourth and the second. So that's 0 1 1.5 multiplied by 0 minus 2. Once you do that, you get your mu n to be 2n minus 1. What is your C transpose X? Minus 4 minus 2 0 0. Help me with this. What is the x1 element? It is the second element of the B set. Second element of the B is तुम लोग लिख लो पहले. अभी now you need to start thinking with me. Keep writing, then you not understand. All this is on the drive, by the way. All this, all my notes are there. But I'm not saying don't write. You can write. Are you done writing? Then help me now. So what is we have to fill the x values, right? So you have to fill xb, the second element, then xn, the second element, then xb, first element, and xn, the first element. Correct? This is how you will fill, because this is 1 2 3 4 indices. So this is minus 4 minus 2 0 0, and what is the xb2? What is xn1? xn2 0, xb1 is 1 and xn1 is 0. Correct? What do you get? You get minus 16. What did be the earlier objective function value? 0. Now it became, and if you look at the mu values, what did they become? Earlier we had minus 4 minus 2. Now it's 2 and minus 1. So you got lucky that one value anyways you were able to eliminate and make it positive. You are only left with one value. So after this one iteration, actually it will stop. It's a nice problem, but it need not always happen. Could be multiple steps where the mu stay all negative, but the function value keep reducing. So it could happen very well. One more observation. Look at xb and xn and look at the xb in your previous iterate step. When you were iterating, no? In that iteration step, if you look at, you had written xn plus to be 4, 0. Are you there? And xb plus we had written as 1 comma 0, right? And we were taking the p or the first index of the b set and moving it to the ends, the second index of the b set moving it to the n set, and the first index of the n set and moving to the b set. So now if you do that swapping, you get the same value. If you had moved the xn first index into the xb plus, you would have gotten 1 comma 4 and the other one could have been 0 comma 0. So you, before the swap, the xb plus and the one you after initialize, they will be same. So this will be equal to xb plus, which was, if you do the swapping and get the xb plus, then this will be that value only. Just to tell you that this is the same thing which is going on. I don't have it on the board, but it's in your notes. Is it making sense? Okay, so we initialized it again. We saw the objective function value. All mu's are not greater than 0, so we are not going to stop. So we're going to select a q with mu q. So what the q value which we select now, so the q is, this is the second index of the n set, which is 2. So q is 2, for which we know mu 2 is minus 1. The next step is solve for bd is equal to aq. Now your b is, I've written it many times, 1 0 1 2 d1 d2. aq is the second column of the A matrix. The second column of the A matrix is this guy, 1.5. I'm going to solve for this. So I will get D as I'll get D as 3 over 4 and 1 over 4. I'm solving it. You'll have to do the linear solve by hand in case it comes in the exam. You can do Gaussian elimination, LU factorization or whatever. So this, both values are greater than 0. So we did this step. Now we have to do the trump card or the main step. Okay, so what is the main step? You have to check xbi divided by di. Okay, I erased all of it. What was xbi? So you have to check xb1 divided by d1 and xb2 divided by d2. What is xb1? 1 by 3 over 4 and the other one is 4 over 1 over 4. So which is the minimum value? 4 by 3, which means that this is your xq plus, or q is 2 now, so this is x2 plus, which is greater than 0, which you got done. Okay, so what was the b we had? The b was, what was b? 3 1 and n was 4 2. Okay, so now what is the other element of the n set? So we got x2, so x4 plus is forced to be 0. Remember, all others are 0. This made equal to 0. Now we'll solve for xb plus. So xb is 3 comma 1 in this case. So x3 and x1 plus is equal to, xb was 1 comma 4 minus d is, you know what will happen, but I'm still writing it down. The d values is 3 over 4 and 1 over 4 multiplied by 4 over 3. So you will get this as 0 and 4 minus 1/3. So you got this equal to 0 and you got this greater than 0. So what is your I here? I is the first index, which is the P value is, the first index of the B set is 3. So that is why you're getting x3 plus equal to 0. It's obvious. It's just matching, everything is synchronizing itself. So now what will you do? So you got all the other elements greater than 0, one element equal to 0, all the other elements equal to 0 and one element greater than 0. So now what you will do, you will swap. So your old B is 3, 1, n is equal to 4, 2. Your new B would be, you have to swap P and Q. Your P is 3 and Q is 2. So you're going to swap these. So that will be 2, 1 and n is equal to 4, 3. So another iteration over. Yes? I'll do the last iteration. It's not iteration because in initialization itself you will see this is the solution. So because we'll just check it once. Hai na? So we'll just check this and then we stop. Alright, so now we'll draw the line and we'll initialize again. To initialize, we'll say xb is B inverse. So now B is the second and the first column of the A matrix. Just don't get confused. I'm writing the index set and the matrix in the same way. The index set is usually with an accent. So what were the element? It was 1, 2 and 1 half. So it will be 1 half and 1, 2. The order is swapped. Inverse of that times 5, 8. This value will turn out to be 4 over 3 and 11 over 3. So your xb now is 4 over 3, 11 over 3. Your xn stays 0, 0. What is your lambda? Lambda is B minus transpose CB. B is 1 half 1, 2 minus transpose CB. What is CB now? It is the second and the first. So it's minus 2 and minus 4 because it was minus 4 and minus 2. So it's just order is reversed. Once you solve for this, you will get this as minus 4 over 3 minus 4 over 3. What is your mu B? It's forced to 0. What is mu n? It is Cn minus n transpose lambda. Cn remains 0, 0. Whether you take 4, 3 or 3, 4, it's just 0. What is your n? N is the last two columns reversed. So it's not the identity matrix. It was 1, 0, 0, 1. So it will be 0, 1, 1, 0. So there will be 0, 1, 1, 0 transpose times this lambda. Once you solve for this, you get 4 over 3 and 4 over 3, both greater than 0. So you have found the solution, but we'll still find C transpose X. C transpose minus 4 minus 2 0 0. Help me fill the X value. What is the first element? It's the second element of the B. The second element of the B is 11 over 3 The second is the first, so that's the, sorry. Correct, no? Second element of 3, B, and the first element, B, and then these two are of course 0. Once you solve for this is minus 17 point something. Whatever, it will turn out to be less than minus 16. That is what we wanted to show, that in the previous step it was minus, first it was 0, then minus 16, now it's lesser than that. You are getting luckier that every step the mu n's are getting positive. Now 100% clear, except the two things which I didn't tell you. Why the swapping leads to a non-singular B, and I also didn't show you that the function value theoretically how it reduces. I mean, example wise you have seen that the new B's are turning out to be non-singular because I'm inverting them. Look, here I'm inverting, here I'm inverting. So in the example you have seen the B's, new B's are becoming non-singular by itself. And in the example you have also seen that the objective function value is reducing 0, minus 16, lesser than that. But now we're going to prove those two things. If itna clear hai. Clear? 100% sabka? Alright, should we take a break or finish it? Finish, okay. So there are two parts now which are remaining. One, failures of, this will, how much time is it? So we'll finish by 4, hai na? We'll finish the failures also. Then we go to the lab, so we'll finish by 5:30, hai na? So we'll not exceed anything more. 1 hour you can code it up. Any questions you can ask me, hai na? The recording will be, where did he go? Okay, so we saw derivation 1 with initialization example, we saw the derivation 2 with iteration and example. Now we're doing derivation 3 where we're going to do two theory things. One is straightforward, the other one is slightly heavy, and then we'll talk about 3 failures of an LP. infeasible LP, unbounded LP, degenerate LP, where the simplex fails. Okay. So to do the theory, we'll do two things here. The very first thing is that the choice of, I think that it will get too big, so you stop and start again. 45-50 minutes is enough because this will take another half an hour because we have to finish two theory and failures also.